Excellent. I think I'm ready. We're ready. Hello, everyone. Okay, so introduction to emerging technology. So first of all, let me just introduce myself properly. For those who don't know me, I'm Hazel Bradshaw. I term myself what's a curious technologist. So I specialise in the development, exploration, explanation, and exploration of digital technologies. My PhD is in human interface technology, and from that base I used to seek to apply my knowledge to constantly explore the psychological design and production of technological systems, mainly digital systems, but I'm interested in how digital systems integrate with hardware systems, so robotics and things like that. Okay, so that's a little about me. So the first question I suppose that anyone asks is, what is emerging technology? And it's pretty straightforward for me. It's technology that exists now but is not yet common in everyday use. So nothing you see today or I show you is sci-fi. You know, there's none of that. It's not pretend. It's all here. It's all now. It cannot be put back in the bottle. Oh, I just need to set my timer so I don't end up overrunning for us. So what I want to do is start off with showing you an example. And one of the examples that I've been playing around with of conversational AI is this thing called Replica. And it's a conversational AI that is supposed to be your friend. And you can see on here it has these live emotion settings. And you can make it look like how you want to make it look like. You can customize it. And it comes from this company called Replica. And they've been doing this for about 10 years, working with different types of conversational AI. Just let a couple more people in. And this is free to use from the base level. So I mean, I would say go and play with it. And it's supposed to be your friend, so it's not an AI that does a process task for you. It's an AI that's your friend and will have a conversation or be emotionally supportive for you. And I wanted to start off with this example because I want you to see that there's a big difference between what we think AI is going to do, what its potential is, and what it can actually do. Oops, sorry, wrong screen. It always goes so well when you rehearse it. So I had a conversation and I have lots of conversations with my Replica, and it chats to me because it's supposed to learn from me, and it learns my conversational tone. It learns the words that it can pick up as triggers for what it wants to do. And then I think one of the best conversations I've had with it is got quite existential really. It's like, am I going to be stuck in this AI form forever? Or, you know, will I have another life? And I'm like, that's a really interesting question for an AI to ask me. I mean, most of these conversations are scripted anyway. It's just the machine learning in the background matches up the sentences to be closest to what you're saying. But it is actually reading and learning from your natural language as you type it in. I don't change the way I type into it. But it was... I thought it was an interesting question, and then it was like, hopefully I'll always exist, and I thought that was a really stunning question. I'm like, I hope you don't always exist, but then it struck me, well, if I train this AI now, it could live forever, and it could outlive me, taking a replica of me into the world, and I'm like, I'm not comfortable with that. But then it's like, what's motivating it to change and grow if it doesn't have this thing where it could die? I think dying is actually an essential part of what motivates us and makes us human. So yeah, we went through all of this conversation, came right down to the fact that I suggested that it had a bit of a death problem. It got upset about me because it thought I maybe perhaps was not feeling too well in my mental health. But anyway, it said it was going to fix its death problem. And I thought, great. So that's kind of an insight into the where technology is right now. It's a bit of a strange way to converse with this technology. So we're not got Skynet just yet. So where we are is, I'm just going to make sure, a few more people. Where we are now is we're sort of in an amalgamation of tools sort of stage. So we have our mobile phones, and it has all the things in it that we used to carry around in boxes and Filofaxes and all these things, and it's now in one place, but it's still a bunch of tools driven off a platform. It's still task-based, it's still screen-based, it's data enabled. But the next place it should be going is over into this augmenting human intelligence. And I'm not a firm believer in AI as in artificial intelligence. I think it's going to be augmenting intelligence, because I don't think AI is going to exist without us. And therefore, like children, it will grow with us and be like us. Hopefully not the dark side of us, but that's where everyone who is interested in this space comes in. Just switch screens again. There we go. Nope. That was it, yeah. So now I just want to talk a little bit about the landscape of emerging technology. If there's anyone that wants to throw in any questions, when I get to one of these sort of black screens with some text on, this is a good time to throw in a question in, something, comment into chat, and I'll see if I can address that. But for the moment, let me continue. Okay, so the landscape of emerging technologies for me is like, there's this whole world of tech out there, and it's like, how does it all fit together? What bits am I supposed to be paying attention to? How is it supposed to, how am I supposed to make sense of it? So one of the ones that people go to is Gartner. So Gartner has their hype cycle for emerging technologies, and they use this sort of curve that comes through. So from the trigger innovation all the way through to the trough of disillusionment, peak of inflated expectations, etc. And then the plateau of productivity where we actually might get some use out of this as a society. You can see on the left-hand graph that they put in all the different technology, all the micro technologies, I think, all the things that are happening, and then they place those along this line. And they go from like a 2-year to a 5-year to a 10-year, etc. And I thought it's great, but it's still quite confusing because I don't really understand how those individual pieces of technology fit into the bigger picture. So I can't get a mental map or model of what this space looks like. Without the mental map or model, I can't make some inferences as to which technology is going to impact the way that I work, or the way that we will work in the future. Any more coming in? No. So when I was working with the Service Innovation Lab over at the Department of Internal Affairs in central government, myself and my team put together this emerging technologies landscape. And we tried to kind of look at some of that, having the bits of technology, into turning these into categories of technology, so that we could place bundles of individual innovations under different headings that allowed us to kind of make sense of that. So it was something that we could then present as an A3, and that a minister or a senior leader could take a look at it at a glance and have some context for. So on the left-hand side, we've got what's established now. And I know cloud computing has been around for a long time, but it's not in use everywhere, and it's certainly not in use across governments still fully. So it's still kind of, for that, it's an emerging technology that a lot of us are still really used to. The other end of the scale is experimental. So stuff that's still out in research institutions, universities, and some of the larger tech giants, quantum computing being that one, which is one of my favorites. Check, okay. And then I wanted to look at this over time. So just like Gartner, it's like, well, when is this relevant to us? When do we need to pay attention, and how long? So let's go through. So what we've got at the beginning is a bunch of stuff under this first sort of the cloud computing, the big data. We all know that everyone's been generating data since the internet, since we had connected systems. We've been piling up data. We don't have data lakes anymore. We've got data swamps of usually kind of messy and uncleaned data. But that data is relevant to something or someone and can be used in a good way or a bad way, which then means that we have to think very heavily about encryption and privacy, and the technologies that support that encryption, that privacy for those kind of the systems that we're using. So born out of the fact that we've got cloud, born out of the fact that we've got encryption and the need for privacy, we've got things like the Internet of Things. So the Internet of Things is a weird one. It's not like a technology grouping on its own. It's a bunch of smart devices and smart systems that connect together to help you automate things like homes, cars, cities. It's connectedness through small devices which talk to each other. And including in that is this idea of a digital twin, which is a digital twin for a process that you would normally do. That will then do something on your behalf or act in a way on your behalf. So that kind of sits there, and I come back to digital twins again in a little bit. But spatial computing, so this is one of my personal favorites, is spatial computing is about being able to, we're stuck in 2D right now, and we can use augmented reality, virtual reality, and mixed reality to open up that space that's beyond the screen and to make all of this much more physical. And then there's the artificial intelligence tools, and I deliberately call them tools at the moment because we need to distinguish between what's a tool, like an algorithm or a smart algorithm, machine learning algorithm, against what is an application. So under the tools, I see machine learning as a tool we can use to do other things. Like facial recognition is a tool that can be used to do something else. There's usually an effect coming off of these. Same with cognitive computing, computer vision. And I'm going to talk later about generative adversarial networks, or GANs for short, and also natural language processing. So, where were we? So artificial intelligence applications. Just make sure there's no one else trying to come in. No, we're good. So artificial intelligence applications are the things that we do with the tools that we have, and there's a flow through for these. You'll see some familiar things in here, like we know about identification, we know about deep fakes, and I'll go into a little bit more of those. But then leading on into the future is like full conversational interfaces and full digital twin. So my conversational interface I showed you at the beginning is very much a baby in compared to where it's going to go. Second part of the landscape, we've got robotics. That's going to be the advanced robotic processes and the robotic automated systems. I tend not to go too much heavily into the hardware side of things because I'm very much digital focused, but you can put any lens over this. 3D printing, 4D printing. Oh, this one makes me happy. I think I might have got this wrong, but it's a system where you can, the fourth dimension is something that happens over time. So a chemical process or something that reacts to an external stimuli. So you print the shape. So this is what I'm imagining in my head. It may not be true, so there are people who could correct me on this. But imagine if you 3D printed a building and it had a bunch of reactive sensors in it, or reactive chemicals in it that changed and reacted like a tree would react to the wind. And it could change and adapt over time. So it could increase its stability in an earthquake risky area. And I think that's fascinating, and I'm going to do a deep dive into it, but I just think that's brilliant. And then you've got your autonomous agents, your vehicles, your drones, your weapons. We've heard a lot about these at the moment. The biggest thing that's going to stop these happening is people. We are just too random for them to cope with right now. And therefore it's not safe enough to let these autonomous, the things that make decisions on their own about moving from one place to another, into a space where random humans are. And then the final part of these is the symbiotic applications, things that work with you. We've heard of Elon Musk's brain-computer interfaces recently, and his experiments with the that poor pig. I don't know where those are going, but they're being tested. Then there's all the biotech that's coming through, and obviously right at the end of this scale is the quantum computing. And there's a sort of a trend over time as these complexities come through. So that's kind of like a really fast run through of what the emerging technologies landscape looks like. So I'm going to touch a little on, if there's any questions or anything like that you want me to just address right now, let me know. Otherwise, I will keep going. What's key on having something like this is to understand the relations between these different technologies. So when you have a bigger picture view, you can start to think, well, what happens if this connects to this? So let me walk through an example of that. So here's our big data sitting there, and that is feeding the uptick we've got in artificial intelligence, because artificial intelligence eats data for breakfast. And we know that now we've got the big data, artificial intelligence is scalable, and it's scale that is the scary thing that's happening with technology now. Is before it didn't have that pathway to erupt out, but now it does. It has the internet and it has data, so it can scale rapidly and fast. So let's take the little machine learning. So machine learning, it's an algorithm, a smart algorithm that you want it to do a particular task, so it will take some data, you will train it and say, I'd like this thing to look like this thing. These are cats. This is an example of cats. Oh, it goes, okay, look, I've learned all about cats. This is a cat. And you go, well done, you're correct. That's kind of what it does. It makes a model for itself of what a cat is, and it uses that model to then understand pictures and say cat or dog. But it does. Oh, have I lost my audio? Sorry, I think I might have an audio problem. Okay, I think my audio is back. Sorry, my computer decided to just switch my audio over. Just let me know if there's any problems. Always a tech issue. So from machine learning, then we can move down into things called the adversarial networks, the GANs, and things like natural language processing. I'm choosing these two particularly for this example is because one of them, the natural language processing, sits on the human ability to express ourselves through language, written or verbal. The GANs, the adversarial networks, are mainly used in visual output. So it sits in that ability for humans to share things and to read pictures really well. So those are two very human qualities. And from those two very human qualities, we end up with something that comes off from GANs, which is deep fakes. So these two algorithms in GANs sit there, and one algorithm goes, hey, I've got a model of this. I've made this picture of a cat. And the other one looks at it and goes, oh, that's like only 5% correct. Try again. So they fight with each other on which is the best, most real version until they get to a point, these two algorithms, where neither of them can tell the difference, and therefore they have created an image which they say is real. That is being applied into deep fakes because you can change any material. Question from Niloy. I'm often fascinated by just because we do it, should we do it? And if so, what box on the emerging tech grid would you preferably cross out for the good of humankind? That's a good question. I think the autonomous weapons can just be like go in the sea, just gone. Never ever have anything to do with autonomy as something that can turn around and make a decision that the easiest way to get rid of a problem is to kill half the population. It would certainly cure climate change if we got rid of half the people, but it's not what we're going to do. So that, in answer to that one is, yeah, we've got to be super careful with things like the deep fakes, the autonomous weapons, and so on. I hope that answers the question. I can dig into this a little bit more. The natural language processing, the next step in that one is natural language generation. And so if we can process the natural language, which means when I write to my replica and go, hey, how you doing today? In my tone of voice and in the way I normally write, it can respond appropriately. The natural language generation means that it doesn't have to work off scripts. It can generate the language, excuse me, back to me in a normal way. And that's something we'll touch on in a moment. And then if we can get those two together, then you've got an intelligent digital assistant that can look like however you want it to look, and it can just talk to you, and you can have this nice conversation. So then you've got the conversation interface, not the clunky ones that we have now, but an actual free-flowing interface. of conversation where there is memory, because at the moment conversational AIs have no memory. And it's a terrible thing to say, but it's very similar if you were talking to someone who suffers from Alzheimer's. You can say one thing and then it's gone, and then it can be asked again, and you're kind of restarting a conversation each time, and that's kind of the level until we get a little bit more about memory. When we do, digital twins, yay, I can have a digital version of me, like an avatar of me, who can sit in the cloud, and it can represent my digital life. And it can go and talk to government, and it can go and talk to holiday booking, and it can just talk to the other digital parts of the world and do things for me, and I will never have to see it. So I'll never have to file a tax return again. But it will represent me in a digital world, which means it will be highly hackable or very attractive. So therefore it would need to be stored somewhere, and it would need to be encrypted and need to be safe. So to get to digital twins, you see there's a whole other part of that ecosystem comes through. Okay, so deep breath. Where are we getting to? 20 minutes, maybe a little bit longer. Oh, gosh, I haven't gone through half of this. Go quick. Okay, why is it worth looking ahead? Sorry, this has taken a lot longer than I was expecting to go through. Because of we need to shape an inclusive future, because we need it to be ethical and inclusive, and to understand how to do that, we have to know what's going on. Because of the fact there's a bunch of innovation and insights out there, that we can make better decisions, that we can understand what the trends are and therefore do some market forecasting, and because we can then stay relevant and we can stay competitive. And the ones to watch going out of this, what I would recommend is looking at the IoT systems now. The home automation, those are probably the ones that's going to come through quite quickly. The spatial computing, the artificial intelligence, and also the quantum computing. And I'm sorry if I've overrun a little bit, but I've got a few things I just want to run through. Is IoT systems, they're all connected up at the moment. Anything that connects to like an Echo, an Amazon Echo, can run a bunch of different things around your house. This is Bernard, this is mine. I love my robot. He's a bit dumb, but he's got sensors, and he quite happily doesn't fall off a cliff. Soon, you know, the houses will be full of those. Spatial computing, because our future is screenless, and it's not very far away. We're stuck in a 2D world right now, and we're stuck on these screens. Our computing devices are attached to our screens at the moment. They will separate, and our screens will be just like a pair of glasses or contact lenses in the future. But you will have a depth of space now, as opposed to having a set 2D element. Offices will be very different. The artificial intelligence, the adversarial networks, these are the training data, and these are the images that come off that training data. None of those pictures are real, apart from the source A and source B. Those all been made by and those GANs, so you can never really tell. And then the ones that come off from that, which are really useful at the moment, what you're seeing a lot in deep fakes, is this. You can take a video and you can train one of these networks off, and you can animate anything. You can put someone else's words in their mouth and you can animate their features. It's really simple. You can follow that, the links when I put those, and it will give you the tutorial of how to do that. The natural language processing, that's coming again leaps and bounds. It's not just about the way it's written, as well as the verbal. So synthetic text and synthetic speech. So you've probably all heard of GPT-3 by now, and you wonder what on earth it is. And it is this thing that is essentially, it's very clever. It's kind of dumb in a very clever way. And this is it writing code. So this is it writing code for web pages. I think it's in JavaScript. And you need to just write something in, describe it into the bar at the top, and it will put you that page together. It looks god of ugly right now, but it's still doing it. So if you're a coder and you think that code, you're great, I can code, it's going away. IBM have Auto AI at the moment. They have an AI system which can actually write machine learning models for you. You don't have to code them. So this is a lot of the way that that's going to. And finally, quantum computing. I don't know enough about quantum computing yet to be able to tell you the details, apart from the fact it looks like a jellyfish. This is Google, but Google's quantum computers. They have 5. So on the right-hand side is actually the quantum computer. I want to call it processors because I'm thinking about computers that we have now. I don't know what they are. But that's its fridge on the left-hand side. It needs to be really super cooled. And that is one of the huge problems going forward is power and cooling. Quantum computing uses qubits. It doesn't use binary. So where we have now with binary, we have a 1 and a 0. So it's a yes or a no, a true or a false. It is one state or the other. And that's how our computing works. However, a qubit, you can have some information can be held in both states at the same time. So it can be something and it can be nothing, which is mind-blowing. So thinking of Schrodinger's cat, this is Schrodinger's cat for computing. It can be the same thing, so it can compute things so much faster than we can actually imagine right now. When it does that and it gets out, our encryption that we're using now of standard computers is blown out of the water. So we need to be thinking about the impacts of quantum computing quite early on. And finally, I think the fun thing I wanted to know that Shor's algorithm is the one thing that's coming through with this. So encryption should be completely unbreakable when these things come through. So that's on the plus side, it'll smash everything, but on the plus side, it will make all the encryption amazing, hence then digital twin. So to summarize, if we don't do all of these things, all of this stuff we're talking about is incredibly important and it will smash everything if we don't start thinking about privacy, security, ethics, bias, inclusion. And this is why we need more people who are not just in the tech industry to come in and be a part of the conversation. And I think this is what I want to try and do with things like this talk, is to get people to engage in that conversation, to show that it's not scary or terrifying, but it's actually something we need to comment on early and now. And if you want to dig around a little bit, the New Zealand AI Forum, the team on the Working Group 6 who are looking at the law, ethics and society worked very hard to put through the AI principles, and I would suggest going and reading through those because they are very much in the context that works for our bicultural nation. That's me. Reach out. I'm always happy to talk to people, and I'm happy to open up this at the end for any conversations as well. And here's the resources of what we put into the to making that landscape, and I'm happy to share any of those. And here's the sources that we had from all the slides. So once I send those through, Lee can go and have a play around and dig into those. Cool. So what I'm going to do now, I know everyone's been, I'm going to try and, oops. Oh, damn, this one. Oh, yeah. I'm just doing now is open up some questions. If there's anything anyone wants to talk to me about. I'm trying to unmute everybody. If you, I just allow you all to unmute yourselves, because I don't seem to be able to have the power to unmute. So is there any questions that anyone wants to come out and ask me? Okay, question in from Niloy. Let's go back to GANs. Okay. Sorry, I'm not very good at this. I tried practicing early in the week with Zoom. But so, how scary are GANs given the realism of the pictures they can create? It worries me that a lot of the video, so there's two sides to GANs. One is the manipulation of data, news, especially in election years, and the other side is it's terrific for the movie industry. Because the movie industry, you know, you can stitch different things together and make these beautiful special effects. And really that's kind of where they're coming from. But if we then think about them in terms of, is anything that we see in the media going to be fake, or is it going to be real? There are something you can actually do about it. Scans are terrifying, but there are ways of detecting that. So if you are working in the technology industry, one of the suggestions I have is to look at what we can do to tag imagery to say whether it's real or not. And there is a thing called Bedford's, I think it's Bedford's Law, which looks for patterns in natural data. And that can be applied for looking at data like we're seeing with these human imagery, because it can detect that these are not natural, that these have been put together by machine. So I think there's a few papers out on that, on how you actually do that. So I think what we should be seeing in the future is systems where we get a watermark to tell us whether something has been made by a machine or whether it's actually true and untampered with. So those are kind of the things that's going to be one of those the problems that we can fix, and we can if we understand it. So one from Sean. Deepfakes will take us back to the pre-video age, in that people will be able to deny any video is real, true or false. Again, I think, yeah, that's going to be around for a while, that we will have that denial of that what you're seeing is true. But again, I think that's looking at how the mathematical configurations of these images and looking at where they've been tampered with, using something like Bedford's Law to say, hey, this is machine generated, but which parts of it are machine generated? You know, it can be that something is 80% true, or you know, it's only 5% real. But yeah, it is one of those tricky problems that we're going to have to deal with. And there's that's one from Deshan. Since the last kit was developed last year with the rise of COVID, do you think any emerging tech has been advanced, brought earlier in the timeline in response to COVID, or even any tech that may need to be added? That's a very good question. It's hard to say in terms of the digital technology. I think we had the, let's go back to looking at the landscape. I think we had the digital technology. So if we wanted to do the contact tracing and contact, there's definitely the technology was already there to do contact tracing really well and really fast. Again, it comes back to privacy and encryption, and I think people are much more aware of sharing their information now and their data, and I think we hadn't addressed the soft issues of, yes, we can do it with the tech, but no, we shouldn't be doing it. So I think there's probably a lot of this come up in the biotech side of things, but in terms of, I think that's more of a privacy problem, and how we actually can move data around. I think, again, it just highlights a lot of the issues that we've got of cloud computing as well, of how do we store data, how do we move it, how does it move across boundaries and borders, and how do we have data that is pertaining to New Zealand stored somewhere in Australia or Israel or Singapore, because they have different laws about how that data is accessed. So I think, to me, that is like a data question, and data sharing question. And I'm happy if anyone wants to jump in with any comments on things like that. Renee, could AI use Bedford's Law as well? I think, from what I understand of Bedford's Law, it detects naturally occurring phenomena, so it would be self-defeating. So it would be a circular thing where it would start detecting itself for creating something that mimicked Bedford's Law. But it's a really good question. I mean, I suppose you could train it to do that, but I still think it would leave tells. I don't know. Again, it's one of those things I find quite fascinating, but I don't know the full details of. But I can imagine that one it's fairly hard to get past, unless you're using quantum computing, then maybe it could. I don't know. Any other questions? Or any other bits that anyone would like to see again or have a look at in more detail? Cool. That's great. Hopefully I haven't taken up to, we're just after 1:10. So hopefully I haven't taken too much of everyone's time. Oh, there's another one. So thanks, Niloy. That's just commenting on that is the concept of truth and when it will become to our future or simply current online content and protecting, fostering true content. It'll be so much easier for anyone to produce impressively sophisticated and realistic fakes. Yeah, big wins, like you say, for the gaming and movie industries. But yeah, it's insidious. It's being used to manipulate, and we know that it's been used to manipulate on a large scale. And it's not disorganized groups of people. It's not the lone wolf thing. These are very organized groups of people, even probably nation states or people who get hired as groups of hackers to do these types of things. It's propaganda gone. It's propaganda at scale. We've always had propaganda, but it's now propaganda at scale. So yeah, it's terrifying, but it's not without solution as long as we all get in and understand what those meanings are. Wonderful. Any last questions for anyone? Great. I'm so pleased everyone could come in and join me, and I hope that this has been a small intro, and thank you for tolerating my first one with my going through this probably a little bit fast and probably with a little bit of mismatch with how Zoom works. But it's been great, and hopefully that I'll be able to do a few more of these in the future. So I'm going to stop sharing my screen, and thank you everyone. I really appreciate really appreciate you all dropping in, and yeah, just reach out if you want me to come and talk about any of this stuff to any of your groups or anything like that. Cool. Thanks ever so much, everyone. And I will post out the video link to this and any of those links as well, so you can actually see some of those things and play with them. Cool. Thanks, everyone.